G+6 modeling and design of reinforced concrete structure in Tekla Structural Designer 2024. So this is a new drawing. So I will new design. So I'll go to material. Make sure all materials are set properly. Materials. So concrete. Okay. Enforcement. Available. Okay. Then close. Then I'll start new. So I'll go to modeling, construction levels, insert above. So this one will be 2.85. Then I have a slab of I have a floor. Here I don't have a floor. 150 millimeter. So insert above, insert above. So 1, 2, 3, 4, 5, 6, or just delete that one. So this one will be my spacing. This one will be 1, 2, 3, 4, 5, 6. This one will be first floor, second floor, third floor, fourth floor, fifth floor, or roof. And then this one will be water tank. My spacing will be 2.85, 2.85, 2.85. That is floor to floor spacing. That is meters. 2.85, 2.85. Then now this one, the source will be 1. Apart from water tank, which is unique, I have floor, 150, 150, 150, 150, 150. Then okay. Then I'll go to grid lines, and then rectangular wizard. For X, I will use irregular. So we need to be careful here. I'll start with 0, 0.775, comma 1.8, comma 1.144, comma 0.729, comma then 1.022, comma 1.025, comma 0.9, comma 0.9, comma 1.025, comma 1.029, comma 0.722, comma 1.151, 5, comma 1.8, comma 0.775. So those are my grids. Then next, previous. So here I will also go with irregular. This is X. Start with 2.5, comma 2.35, comma 2.173, comma then 1.1 2 3, comma again 2.8, 2.8, comma so this one should be 1.124, then again 1.124, comma 2.173, comma 2.35, comma and finally 2.8. Next, previous, just finish. Okay, so I will start by modeling my columns. I'll go to concrete columns. These one are going up to roof. Column concrete cast in place. Change the class to that class. Change this one to 200. 200 by 400. Okay. And place it there. Yeah. yeah, 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 and there. So so again, I do the same thing this side, there, there, yeah, and there. Then place other columns here, jump to there, then other column here and there. Um, other column here, here, there, and there, there, and there. And also do the same thing in the lower side. Um, then here, this column will go there. Then here, this column will go there. The same thing here and there. Also repeat the same thing on this side. Hmm, hmm, hmm. Okay. Then I'll change this column new this time 400 200. Okay, now these columns will be placed in these two places. When I'll go to this levels, I'll go to story 1. I'll go to beams, cast in place. I can use class 25. And I'll change this now to 200 by 450. I'll also change these covers to 25, 25, 25, 25. So before we do, you can check the 3D, can see what we've just created. So let me go back to story 1. So we want to model our beams. I'll start by this point, double click at that point, double click at that point, and this from here to there, 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 here, and do the same thing on this side. Here, uh, okay, I need another column, another beam. Okay. Um, there. So this one will go from here, there, from here, there, from here, there, from here, there, there, there. Okay. So I'll have to undo that. This one is needed at that particular point. So this one from here, there. Okay. There, there, there. I want to avoid intersection errors as much as I can by making sure that I click at every point where there's an intersection. Mm. So this one I undo because it's not going straight. From here, there, 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 and there. I'll escape to release. 25 cover, 25, 25, 25. So I need the column here. A beam there, there, and there. Then this one is going from here, there, and from that point, then this is going from this column, that point, that point. Okay. This one is going from here, 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 here. So this one I can just right click on my mouse. From here. Um, I have another beam there. At the midpoint. So I need another beam at that point, that point. That is for my staircase. And then we can go to here and validate. The model geometry is okay. So you can check the 3D. Just make sure you have no intersection errors. Okay, so after that, I'll go back to first floor, and then I will start to insert my my slabs. So I'll go to model, slab, overall depth is 150. Class 25. I'll go to reinforcement, then change all this bar to T10. So I'll expand this top bar, bottom bar also T10, here also T10. Also change the cover to 20. 20. Then insert here. Yeah. There. I have a void here. Yeah. This is my staircase. I have another here. I have a void there. Then again, this is my staircase. So let's see the 3D. So validate the model geometry is okay. So I can go and go to roof. Then I can add column. Level is from story 4, story 5 to that story. Now from here, there, there, and there. Then I can go to this story, add beams. Change the class to 25. Yeah, there. Then I need to divide this by 2 because it is water tank. Then after that, I need a slab. For water tank slab, it is usually 175. Again, class 25. Now this time for reinforcement for water tank, it is usually T12. This is typical. Use T12, and it will be T12 top and bottom. So you can go to 3D. And I'll go back to first floor. And I'll go to loading. load cases. I have all these: self weight, including slab, self weight, dead, service, imposed. Combinations. I'll generate for final, finish, then go now to envelope, add. I'll select that, select all, then okay. Then I'll go now to which load. I'll add okay, I'll add dead load, patch, area load. For finishes, I'll just use 1 kilonewton in all slab. And I can go to water tank and also add dead load, patch, area, finishes for 1 kilonewton. So you can go to 3D and go to load. You will see they assign dead loads. So I'll go back to story 1. Okay, now again a dead load of there. Now I'll go to now impost, again patch, area load of 1.5 for residential. On all these locations. Right now, if I go to story 6, I can add impost 1.5 again. So I wanted to find water tank. Let's say I have a water tank of let's say if I open notepad, I have a water tank of say a size of 10,000 liters. Okay, that is the water tank liters. This is equals to 10,000 kgs because the density of water, remember, is 1, right? Now multiply, change 10,000 kgs to newtons, should be equals to times 10. Now to change to kilonewton will be times 10 all over 100. You'll find that this is equals to 100 kilonewton. Now to find the area load will be 100 kilonewton divided by that. That will be divided by the area of water tank, that will be 2.8 divided by 2.8 times about 2.3. 2.8 times 2.3, that would be around, let's say 6, right? So this 100 kilonewtons divided by 6. You get that is you get is equals to 1 carry 4 60, 16. So let's say 14 kilonewtons. That is the dead load from water tank. Then so I can add dead 14. That is for water tank. That is area load in here and there. So if we go to 3D, you can see the loads assigned. Now I'm going to load cases. I will add this one. I will call it I'll call it wall is dead. Then okay. Then I can go to first floor. Now change this to wall. Full UDL. Maybe I'm having a wall of masonry wall of about 20 kilonewton per meter cubic multiplied by thickness 0.2 of wall multiplied by height. That will be about 2.85 divided minus the height of beam of 2.45, 0.45. That will be times 2.4. If you do the maths, you get about that is 4.8 times 2 should be equals to 9.6. A line load of 9.6 kilonewton meter. So cancel. So I just reduce. So this full UDL is a member load. Should be 9.6. In all those walls where I'm having a masonry wall. So I will add in all these. Adding in all those locations. I have another also wall here and here. Okay. So if I go to 3D, you will see the line loads or the wall loads are assigned. So this one I can change to wall. Can see the wall loads that I've assigned to my beams. So I can go to model verification. The model geometry is okay. Now We go to analysis. I will not analyze for earthquake, and for, maybe I can add. Let me go to model. We need to add maybe some wind load. So to do that, we need to model some wall panel from maybe from this floor. Um, Let me add some wall panels in here. Okay, let's say it's ready. Apart from maybe you hit escape. This one, this one. Maybe we can go to wind load, wind wizard. Next, 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 finish. Maybe let's validate the model. Can just hit here. So the model has some error. Just expand which wall and which wall. That wall. So I'll select one and hit delete in my keyboard. Delete. And then let's do the model check. The model is okay. Then can go to analyze all static. So so you not assign those wind load properly. But it was not my intention to do wind loading in this video. So let's see if we can do the design. Design all static. Okay, because the model has error, it has not been designed. So I'll go to model, escape, hit escape. So I'll delete all this. Hit escape. Um, I can try to go back. So I can delete wind. Yes. Then validate model. Then I'll go to analyze all static. So if you have any model error, then the design will not happen. You can see the results, forces, stresses. So I will just uncheck all of this. Okay, so now can go to analyze, design all static. So the building is so complex and big, so the analysis is taking a few minutes. So we'll have to wait. Analysis. I was expecting columns to fail. So all columns have failed. All beams have passed, but there is a few warnings. I was expecting the columns to fail. So I'll go to here and select just the columns. Wow, let's undo that. Escape. I need to select, so you need to escape before selecting. I'll select those apart from that column, holding control, and that. We again select all columns. Then change the class. First, the class was wrong. Need that class of column. Again, analyze static or that building. You cannot use class 20 of concrete. It's a G+6. Then go to 3D, design, concrete gravity. Let's see if we will pass the design. So you cannot use class 20 of concrete. You have to use class 25. The other option will be to increase the size of columns. So the other option, I can go to base, select all columns, I'll go to property, edit, use 250 by 400. The same thing, edit, now 400 by 250. Now again, I want to go to modeling, supports. First, I will need to delete all the supports. So I select and click delete and check members and suppose just supports. Then I'll need to model supports of my own. I need fixed support. I don't need pinned support for reinforced concrete foundation, column foundation. It has to be fixed support. You can also do like that. Okay, like that, on that, yes, those points, but make sure not to pick anywhere that you don't have column. And if you go to 3D, you can see now I'm having, so I can just again do validation check. Model is still valid. Then I can go to foundation. Let's go to my base. Foundation, part base to column, green square, depth 750. Now this time for part base I can use that class of concrete. This one I can use 2000 by 2000, a depth of 500. My bottom I can use bottom bars 12, 12, all 16, 16. Okay, now I can insert my part bases. Let's go to 3D, just like that. So let me first check my model. Okay, insert my So a good foundation, part basis. $2,000 by 2,000 by 500. Again, not class 20. Can use now class 20, not class 25. My soil bearing capacity is 200, not 100. 200. Then okay. So I'll not just do the exact because some bases are combined, but this is just sample model. So you just go with single footing, although this is not realistic. Maybe if you get time, you can do it correctly on your own. So I'll just again repeat, analyze all static. Then design all. I can design either static or gravity. But if you want to go from most critical, you go to design all static. I think you include not only gravity load but also lateral loads. Due to my walls, I assume that all my columns are braced. So I will only analyze gravity. As expected, this column here has failed for water tank because of the water tank load. And also because I did not change the dimension. So if I click these columns, I forgot to change the dimension. Double click. Now cancel. Just holding control to select all. Just change to 50 by 400. Okay. Now we can analyze again. Because I have masonry wall, my walls are braced. So I will just analyze for gravity, and also because the location doesn't have is not prone to earthquake, but that is not justification. I think you should go for static design, which is the most critical. That is, you include lateral loads such as wind, earthquake, etc. And I think the failure of is just that maybe a depth of 200 is not allowed. Okay, so this one I can just escape. I want to see status. No. I want to see the status. I have no failed members. And if I click my column, for example, let me go with this staircase column. Report for member. Can see pass. 6H12. Never use H12 for column. I'd rather go for H16 or T16. Never use T12 for column, especially for that kind of building, which is you can see G+5. The minimum you can do is 16. Don't go with this size of column. My beams, report for member. So you can see because it's suggesting tutorial, I think 400 by 200 was passing. It's just because of the setting that dimension of 200 column is not allowed. Maybe the minimum dimension you should allowed is 225 by minimum is 225. So that's why 200 by 400 was failing. You can also generate a drawing. Just click. I'll click here and then right click, right click, right click. Then generate drawing. AutoCAD will open automatically, and then you will see that the drawing for that particular column. We have not analyzed for slabs. We need to analyze for slab to check deflection and if they have passed. So deflection check is very important. The minimum deflection should be not more than 500. That is 500. That is Ly divided by 500. So Ly is the Lx is the small span. Ly is the long span. So the maximum allowable deflection should not be more than Ly over 500. So let me let's go to design. We can design slabs. You can see all slabs that are passing in terms of design, but are we sure of deflection? So if we go to slab deflection, analyze all, you can see all slabs have passed, but we are not sure if they have passed in deflection. So you should always check if these slabs will pass in terms of deflection, because there is, according to code, there is minimum deflection allowed. So you can see the maximum deflection I'm getting is about 17 millimeters, and it is here at water tank, right? So this deflection is too big, and that's why you can see to solve this problem you need to go and increase the depth of that particular slab. It means the load here is too much. For this deflection, I think this one is within range. It's 11.7, and if I check here, yes, no problem. You can see what we are getting here. To 50 by 400. So if I go to this, you can see that the span is from here, from here to here. If I go to dimension, Ly is a long span. This is about 4.89. That is meters. So this is 4898 meters. So this one divided by 500. That should be the allowable deflection. So that you can go to calculator. The allowable deflection should be not more than, let's say 4900 divided by 500, because that is the ly. 9 point, this is the maximum deflection allowed. Therefore, it means that this is failing in deflection. These greens are failing in deflection because the maximum allowed is this color and below. So that's how we do deflection check. You can just also go to design, to foundation, design part basis. I'm expecting some failures, or you have to increase. I'm expecting failures, but I will not focus on design part. Maybe you can focus on design part in the next, but all members have passed. If I click here, generate drawing for members, okay. I see H20. So to be able to, at 300, to be able to reduce this size of uh, uh, this size of this one is very correct, but maybe it's not very feasible because for pad basis you don't need to use T20, so you can use maybe T16, and to do so maybe you increase this width and breadth and depth, and then we check for the size that passes at T16, maybe at 200, and also reduce the spacing between riba to 200. So thank you for watching this video. I'll see you in the next video.